Hi, everyone. Welcome, and welcome to our Twitch viewers online. We have a special session for you today. This is our second session of the day. We have Frank Munz, who is a senior technical evangelist at AWS. He'll be covering getting started with streaming data in your applications. So, good luck.
Thank you. So, good morning, everyone. Guess you can hear me? So this presentation is a very gentle introduction to streaming data. Can I have a raise of hands who's working with streaming data today? Yeah, I guess that's like 40, 50% almost. Cool. So if we talk about streaming data, what we really mean is small-sized events that are continuously generated and that typically come with a low latency requirement. And one of the most popular and probably the most famous streaming data projects, open source streaming data projects, it started at LinkedIn, and it's Kafka. So this presentation will explain you both. It will explain you the open source world of Kafka that we do now in the AWS cloud as a managed service, and we also talk about the Kinesis suite of services that we offer. And I will cover both. So talking about Kafka, they created it to do clickstream analysis. That was the purpose of creating Kafka. And if I talk to streaming data to developer, very often those developers think like, how difficult can it be with this small size data? No, what's the big difficulty in dealing with this small size data? So there's a blog posting from the Kafka people, actually I think from Jay Krabs. It goes back like 5 years. And everyone is complaining about having massive amount of data, and you can guess LinkedIn, they all have your data, they have my data, we all have our profiles, so you can guess they have a lot of data. And in this blog posting, they explained that if they look at all the data that they have in their relational databases together, it's smaller than the amount of events they capture in one single day. So it's massive amount of data that is processed in one single day only, if you compare it to relational data. Then the other thing where this constantly generated data is coming from is machines. And there is a study out that says like 40% of all data next year in 2020 will be machine-generated data. So the big danger is that this will be a lot of dark data. It's data that we generate, that we produce. We probably store it somewhere, but we never really evaluate it. We never work with this data. So that's one of the big challenges. And the third one is this continuously generated data. Means if you're sitting here, you probably have database services running, you probably have application servers running, you have web servers running, and they all constantly produce log files that you want to analyze. So talking about streaming data, if we generate it continuously, we also want to process it quickly, and we need to transform it quickly. That's important. Now, the difficulty with streaming data is that it's not static. No, you cannot have a static snapshot of your data and then process the data because it's constantly changing. So the challenge is how to work with this streaming, always changing data. And the answer is the only thing that is not changing is if you go back in time. This is why we work with sliding windows. We go back like half an hour in time, and we say, what was the average temperature for the last half hour? So we work with aggregates, and we work with these timed windows if we talk about streaming data. And the other question very often is, why the fuss about having the data processed so quickly now? Why is it so important? Couldn't we just have more time? Now, if you look at this curve, and if you look at the right end of this curve, if you have data that is like a couple of years old, so if I try and sell you an application that tells you, like 5 years ago, you were running 12 machines, how much money would you pay for that? That's almost worthless now. This is what we call historic data. That's what you used to burn on a CD-ROM. Today, you would store it in AWS Glacier. That's the long-term storage that we offer you for a super cheap price. But it's not really exciting now. If you move more to the other side, to the left-hand side of this curve, and you have a system that tells you, while you're sitting here, maybe from your 80 machines, 75 are going down and are in a critical state, that's much more alerting now. You want to react on this, and this is also why we call it actionable data. And if we move a little bit further left, and you have real-time data, and you feed this real-time data maybe into a machine learning process, and the machine learning process is kind of listening to what your machines are doing to the noise of the fan, and he says, look, this sound is getting a little bit strange, and it's alerting, so I'm going to predict that soon this machine will fail. You have the chance to preactively kind of stop the machine and make sure it's not breaking completely. So having this actionable data or preventive, predictive analysis is very important. And I always like to say, it's not the data, but the value of information is not aging like red wine. It's not getting better. It ages like bananas. So at some time, it's just not important anymore. As I mentioned, today I want to talk about both. I want to talk about the open source solution that we offer as a managed service, Kafka, which is preview right now. This is why I'm not going to do any demo. That's the MSK, Amazon Managed Streaming for Kafka. It's public preview. You can try it today. It will be general available this year, soon. And the other one is the Kinesis suite of services that I want to introduce you briefly. So this is just a brief overview to get you an idea of the choices that you have. So if we talk about MSK for Kafka, this is how it started. Probably you've seen this slide before if you've been to any Kafka meetup. This is how they motivated the usage of Kafka. This is how the architecture at LinkedIn looked like before they introduced Kafka. Do you like this kind of architecture? No, you're shaking your heads from left to right now. What's the problem? The problem are all those connecting lines. If you're a mathematician, you would say, if you have n entities and you connect them together, point to point, what you get a squared complexity. No, this is like a squared complexity is like super bad thinking about how else it could be. Now, what they did is they introduced Kafka, this log, this semantic log, and what you get is you have like a bus in the middle. And what happens to this squared complexity? It's reduced to a linear complexity. And this is much, much better. And this is like an old trick. No, it's not new for Kafka. We used to do the same with, with messaging systems, with the service buses. But it's just the same architectural principle that helps us a lot. So one is reducing complexity. That's very important. And the second one is it's also decoupling. And now why is it decoupling? Well, it's decoupling because we have something in the middle. This is actually where the word middleware comes from. And it's decoupling because, well, the sender or the entity that is creating a message is talking to the Kafka topic, is sending a message to this Kafka topic, and then the Kafka topic stores it or, well, keeps it for a while, and then you can read it from there. But it's not directly talking to the entity that is receiving the message. So it's decoupled. And if the entity that is receiving the message, the consumer, is not available for a while, it's not a problem because it can read the message later. Now, of course, the question is, what if the thing in the middle is not available? And we need to talk about this. That's actually one of the most important concepts, getting a good understanding about the HA availabilities of Kafka and why this is sometimes not so easy. Now, if we talk not about the messaging, that seems a bit like old-fashioned, but if we talk about microservices, also Kafka or messaging or event-driven systems make a lot of sense. Number one is event sourcing. This is where you don't store the final state in a database, but you keep the events that lead to this final state, and you can reprocess those events, and you again get to this final state. Now, I'm not a database person, but in my career as an IT architect, we had several times the requirement to use a database, but then not to keep the final state, but to also keep the events that led to this final state. Now, try and model this with a database. It's possible, but it's not so easy. No, you have to have timestamps and an order, and it's like a lot of extra work. If you do this with a streaming system, with an event-based system, you just keep the events, and you can replay the events. So that's very easy. The second one is called CQRS, Command Query Responsibility Segregation. Long, long word. What it means is we have commands and queries. Commands is like you write, queries is like you read, and you want to separate them because you can optimize them in different ways. So the commands, the writes, you can also use them for event sourcing. That's the purpose behind CQRS. And the last one is like choreography. It's the classic thing is choreography versus orchestration. And which one should you take? If you have events, you can very easily trigger an action based on an event. If you want to trigger 2 actions based on 1 event, you just connect a second action. It's very easy to do that. And you don't have to have a centralized instance that is running a workflow. That's not necessary. And that's what we call choreography. And it's choreography like in a ballet. Have you ever been to a ballet? In a ballet, the ballet dancers, most typically, they don't bump into each other, no. They just know how to dance, and it's just working magically somehow. And the difference, the opposite is a classical concert, a symphony, where you have a conductor in front. Now talk to the experts. They will tell you, even if you have world-class musicians, and you sit them together and you let them play, it's not sounding well. They need this conductor. So the conductor is the centralized workflow that we sometimes need. Sometimes this is the better solution. No, I'm not telling you choreography is always better, but sometimes it's also not the better solution because it's, you need this orchestration, this workflow system, and sometimes it's easier to go for choreography that can be extended in an easier way. And if you work with events like Kafka-based events, that's a very easy solution. So you should always decide which one to choose. I can't tell you this is better. It's your choice as an architect to make the best solution. But keep in mind choreography versus orchestration. And the last one, and I need to admit that's a very dramatic example of Kafka usage, is the New York Times. What they did is they kept every single article in a single Kafka topic and every single article since 1851. Now imagine this, it's one big Kafka topic. It's set to never expire the messages, so the messages will just stay in the topic. If they have consumers, they connect them on the right-hand side here, what you see here, and the new consumer can reread all those messages from the topic. So that's the technical architecture they decided for. It's a bit extreme, and when they published it, there was a lot of discussion, but it's just something to keep in mind that this Kafka topic can store messages forever. They don't have to expire. And that helps us later if we try to understand how different other systems are working. Now, Kafka, at its core, it's a commit log. It's not a log like the log file from your Apache web server, but it's a log data structure. That means what we do is we have producers, they produce messages, and those messages, they are produced, and they are kind of appended to the log. So at the end, they are appended, and it doesn't really matter if you have like 100 megabyte in this log already, you append one message, you have a gigabyte, or you have like a terabyte already, it's always the same amount of time that you need. So sending messages to Kafka has always the same overhead. That's why it's very popular. If you read it from the other side. You typically read it with an offset, so you can have a consumer A reading offset 1, then 2, then 3, then 4, and you can have a consumer B reading the same messages. So one very important principle is that if you read the message, it's not taken out of the topic. It's not like SQS, it's not like MQ series, it's not like JMS in Java. It's a small difference in the semantics that makes a big difference in how you use it at the end. And the thing is, you can have different producers that reread the messages. Actually, it even goes that far that if a consumer goes down, it can just reread the messages and rebuild its state. Remember this event sourcing that we talked about? That's the principle. So that's the core thing. If you want to know more about this, there's a really nice book. It's called Hard Logs. It's really written hard. It's a small book, like 60 pages, and that describes like the core of Kafka. I highly recommend it if you want to know more about this. Now, I told you it's a commit log, and it's not the complete truth. It's actually a partitioned, replicated commit log. It is partitioned because we want to run Kafka across different machines. That's why we have brokers on each of the machines, and we put them together in a cluster. That's why we have a cluster. And then we have topics, but it's not a topic, a single topic. The topic is partitioned. So we can partition a topic across different brokers. And here you see 3 partitions for this topic A. Now, if there is a producer, the producer is writing messages across those partitions. And you can decide, if you give it a key, it will hash the key, and then the hash of the key determines which partition you're writing to. If you don't give it a key, it will just do load balancing and you spread your load across those different partitions. Now, if you use a key, a very useful key, for example, is the session ID, because it stays constant for one session, and then all the data for one session ends up in one partition. That makes a lot of sense. And in one partition of a topic, you also have a guarantee for the ordering. That is very important. Just imagine you order something like very expensive, like a nice sports car, and then you need to cancel it, or you reverse the order. You just get the cancel first, and the destination system says, well, I don't really know this order ID, so I ignore the cancel, and then the order comes in, and the order will be fulfilled. So the order of cancel and order something is super important. Then that's not all. There's more to it now. Like the Kafka system itself needs a second system that is called Zookeeper, which keeps state. So all the state, like, for example, where are the partitions for a particular topic, is kept in a separate system, which is called Zookeeper. So Zookeeper itself is a different open source system. You could use it separately, but if you want to use Kafka, you have to use Zookeeper. That's very important. It's a critical component, and Kafka today is not working without Zookeeper, so you have to have it. That means you also have to set up Zookeeper. Now, if you set up Zookeeper, it keeps the state. That tells you it should be high available, because otherwise, if you only have one instance and it goes down, you lose the state. So what you do? Yeah, well, you have more than one instance. You take two. If you take two, again, it's not very suitable, because if you take two and you have a network split, those two instances are separated. And then we have what we have in distributed systems. We have this quorum algorithm that says, you know, I know the configuration that says n equals 2. I see I'm alone on one side, and they try to build a majority. So the majority of the systems continues to run, and the minority shuts down. But if you have two, what's the majority? It's not working. So you need at least 3. Okay, so 3 is good, 4 is not good, because it's an equal number again. 3 is good, 5 is good, 7 might be good. Now the question is, where do you put them? So I've done several Kafka projects, and one of them was for a huge German company, one of the biggest companies that we have, and we had 2 data centers for high availability, like one in Berlin East and one in Berlin West. Now, imagine you have 2 data centers and you have the task of distributing 3 Zookeeper processes across 2 data centers. How do you do that? It's not really working well. So this is where you see, like, the scalable open source software that we have these days is working really well together with the clouds, where you have like at least 3 availability zones. So the cloud is pushing open source, in my opinion, and open source, the scalable open source, is working really well on the cloud. And very often it doesn't work that well if you only have 2 data centers. And then it goes on, because we have those partitions to have things running in parallel. So imagine a message in such a partition times out. It needs to be cleaned out of the partition. And whatever happens per partition is scaling across those brokers, because the bottleneck will be on a partition level. And we also have replicas, and those replicas make sure if a partition goes down, you have a second copy. So the replicas, they are to make your data higher available, to not lose your data, and the partitions are more for the throughput. And all this you need to understand somehow. And what I'm trying to tell you, this is not super complicated, it's not rocket science, you can learn it, but you have to understand it now. If you don't understand it, it will be super hard to run Kafka in production. And I've done projects, I've done 2 big Kafka projects on premises, and the experience was the same in both projects. It took us, like, in the first project, 1 week for the implementation, for the coding, for the development, and in the second project, it took us like 2 weeks. But then, in the first project, it took us 5 weeks to explain all the rest, like to explain how to install Kafka to the operations people, how to start it, how to patch it, how to upgrade it. Then think about all these configurations. How many partitions would you take for a topic? How many replications do you want? Where do you put your 3 Zookeeper processes if you have 2 data centers? And having 2 data centers is not bad for on-premises. So all these questions, they are not so easy to answer unless you have a really strong operational knowledge in running Kafka. And this is not something that you want to give to people that normally run databases, or that are operations people that know how to restart a process if it has failed. You need more knowledge about this. You can acquire it, but normally the classic operations people that used to do restart processes, they don't have it. So at the end, there are challenges to operate Kafka in production. And there are various challenges. I come back to them. And the question is, why do we offer you a managed service for Kafka? This is a quote from Gwen Shapira. She's one of the top consultants for Kafka. She is working in the company where Jay Krebs is working today. He's the guy who started Kafka. And she basically said, there's a talk about all the details about the hard things about running Kafka. And she says, look, in 99% of all the time, the basics go wrong. So it's upgrades or not doing upgrades. It's monitoring and disk space. And I want to address all those three topics by talking about MSK and why MSK solves these problems. So the way to solve it basically is we do the operations for you. We give you an easy way to create a Kafka cluster. And remember the Zookeeper story, the 3 Zookeeper processes that you maybe need to distribute across your 2 data centers? This is Zookeeper. It's gone. This would be the marketing message. I'm a techie, I have to confess. So it's not gone. I'm telling you, it's just hidden. So we hide it. We do it for you. We know what to do. We know how many we should deploy. We run it under the hood. We make it highly available. And you don't even pay for it. So basically, honestly, you can forget it, because you don't need to think about this Zookeeper anymore. It's managed in the background and in the control plane. It's like a solved problem. And it's one of the hardest problems in Kafka operations. So forget about the Zookeeper. Then how to get started with the MSK that we offer to you? Well, easily, there is, even now in the preview, you have the console. In the console, you say, I want to create a new Kafka cluster with this name. You pick the version number, like version 2.1 or 1.1. You define in which availability zones you want to run. And then you define the size of the broker instances that you want to have. So it's M5 instances, but you can define if you want a large one, or do you want a 2x large one, or 24x large one. You define the size of those instances, or you go for the command line. This is what you see here at the bottom, where you can also create or list or configure your Kafka clusters. Now the pricing, how do you pay for it? The interesting thing is you pay for the broker nodes that you just created, and you pay for the storage. But you're not paying for the Zookeeper, I promised you. You're not paying for the topics, and you're not paying for replication traffic. So all the hard things that we do, they're kind of hidden. You don't pay for them. You just pay for the broker instances and for the storage. And that's the part for Kafka. Now I try to explain you Kinesis quickly, and then we compare it. We try to find the first rough rule of thumb. When should you go for Kafka, and when should you go for Kinesis? Let me just see the timing. That looks good. OK. So Kinesis is not one service. It's a family of services. It's actually 4 different services that we have. And the first one is Kinesis video streams. This is where you can ingest video sources, like from hundreds of millions of different devices, and you can stream video on demand or live. This is not what we're covering here. The second one is called Kinesis data streams. That's the core. That's the most important one that you need to understand. So if you walk out here in 25 minutes, you have to have a good feeling of Kinesis data streams. This is where you can ingest data from various sources, and it keeps the data. There is no operational overhead, and it's real time. So it works with very, very small latencies. The third one, Kinesis data Firehose, is like a managed consumer. We take the data and we write it to an AWS data store, such as S3, for example. Or the fourth one is Kinesis Data Analytics. I'm going to quickly show you this, where you analyze real-time data without starting servers. So it's serverless data analytics. And there is a SQL part to it, and there is also a Java part to it, which is new, which we announced last year in November. So Kinesis data streams overview. Kinesis data streams it's like a buffer. It's like a pipe where you connect the producer to the consumer. And the producer could be a mobile SDK. It could be a classic SDK that you run in any kind of client. We have a special Kafka producer library that is also batching and aggregating messages. And then you batch them, you aggregate them, and you put them in a Kinesis stream. And you can also have a Kinesis agent that is running on a client side, collecting log files from your web server, from your database, and taking the lines of the log files and putting them into a Kinesis stream. So basically, it decouples and it gives you those real-time possibilities. If we think about the performance, why is it so performant, or how can you make it performant? There is two things to understand. First of all, we talk about streams. And if you start with a Kinesis stream, you give it a stream name and you give it a number of shards. And if you have one shards, a stream of one shards, you can write 1 megabyte per second to it. And you can read with 2 megabytes per second. Now, if people hear this the first time, they say, why can you read more than you write? The thing is, maybe your consumers, they fall behind and they want to read more. Now, if you need more than 1 megabyte in write performance for your producers, you can simply increase the number of shards. So if you have 2 shards, you get 2 megabyte. If you have 5 shards, you get 5 megabyte, and so on. So you can scale the throughput, and you get a guaranteed throughput. Now, you're all sitting here, you're very quiet, but if you think about this, this is amazing now. Try to do this in your data center at home, or try to replicate this. How would you have done this like 10 years ago? It's very hard. Even if I give you all the money that you need, and I tell you, build me a system that is real-time capable, that does 10 megabytes per second in and 20 megabytes per second out. Which hardware would you buy? How would you configure it? Now, in 1 week, I changed my opinion. I say, no, now I don't want 10 megabyte. I want 50, then I want 100, and I want to go back to 5. That's a super hard problem. We solve it for you. Now, I'm telling this because people just type in the numbers, but there's a lot of technology happening behind these numbers, and you really get this guaranteed throughput, which is a cool thing, which is a very amazing thing, actually. Now, something new happened in this area, talking about performance, and it's about the reading data from a Kinesis stream. You can read 2 megabyte per second per shard, but this is shared for all the applications that read from this stream. If you have a lot of applications, this can become a bottleneck. So what we've done now is we have a new kind of client, and this client, you register it, you call a method which is called register stream consumer, and then we're using HTTP 2. Now, HTTP 2, as you know, it keeps the connection, and we can push data to the consumer. And this is why it's faster. It's like 65% more efficient. And we can have this 2 megabyte per second per shard per application now. So every application can have this dedicated 2 megabyte per second per shard, which is removing the bottleneck. So for those who want to read a lot, this is the new kind of client that you should use. Then I told you about Firehose. I said it's like a managed consumer. It's a consumer that we manage and that easily allows you to write data, for example, to S3 or to Elasticsearch or to Splunk or to Redshift. And what it does, we have a data producer that is writing this data to Kinesis Data Firehose. The data producer could be a data stream. It could be an application that is using an SDK. It could be a mobile application. It could be all those possible clients that I already told you about. So it's writing the data to Kinesis Data Firehose, and then Kinesis Data Firehose is writing this automatically to S3. Could you program this yourself? Yes, of course. You could write the producer yourself that is writing to S3, but why should you? This is a client that we give to you. We scale it for you, and it's very easy to use. It's just configuration, and then you can use it. On top, what you can do is, if you have incoming JSON data, we can convert it for you. We can use Glue, which is a crawler that finds out about the data structure of your JSON data. It's using the data structure of your JSON data, and it's then converting it to either ORC, which is an open source format that originally comes from Facebook, or to Parquet, which originally comes from Twitter. I think they both happened to be published like within a month in 2013. And they're both columnar formats. So what happens is they store data in a columnar way. Now, if you think about it, why is this interesting or why is this exciting? Remember the IoT example that I gave you. Remember, imagine you have data coming from a sensor, a temperature sensor that says sensor 17, 28 degrees, sensor 17, 29 degrees, sensor 17, 28 degrees again. So if you convert this to columns, the first column would be sensor 17 all the way down now. Imagine you need to compress this. That's super easy. Now you can say you have like 328 times sensor 17, so that's super easy to compress. So what these columnar formats do, they compress it automatically. And sometimes if you work with the data, with big data applications, you also don't need to read every single column. This is why those columnar formats make a lot of sense. It's compression and then reading less data than you would normally do with a database. So this is why this mechanism of using Firehose for storing data makes a lot of sense. I told you that we have two ways to analyze data in real time. One is SQL-based, that is maybe more appealing to database people because it's the common language, you know, for data access. And the other one is based on Apache Flink. It's Java-based. Now, the SQL one, I did a small demo that I can show you. It's basically what you do is you have an incoming stream, and you create an outgoing stream, a destination stream. And then you select, using a normal SQL select statement, the columns that you want to take over from the incoming stream, and the aggregate functions that you want to use, like min, max, or whatever. And you define the timed interval at what you want to create the output. So it goes like this. This is where you see the data. And zooming in. So it's saying insert into this destination stream. And then you see the select stream, and you see the columns. And you also see the aggregation functions. And it's taking the data from the source stream and writing it to the destination stream and using those aggregate functions. And it's grouping it by these timed windows that I told you in the very first slide. Now we need these window functions because otherwise we couldn't really analyze streaming data. So that's one way to do it. The Java way I'm not showing you in this presentation. It's a bit longer to explain. It's based on Apache Flink, which is another standard library. We can do it serverless with Lambda functions. You know Lambda, the function as a service where you run a function that is scaling automatically, where you don't provision the infrastructure. It's highly available. It's automatically running across availability zones, even though you don't have to configure anything, and you don't pay for it if you don't call it. So this is the benefit of Lambda functions. So with the Lambda functions, a Lambda function reads a number of records in a batch, and then it invokes your function synchronously, the function that you provide, and it gives it an event containing all the records that it was reading. So the Lambda function is basically processing those Kinesis records in a serverless way. The thing is, there is a maximum execution time for such a Lambda function, which is 15 minutes. If you get the records in a batch, you have to be careful, because if you read too many records, maybe you exceed this maximum execution time. And I can't tell you how many records you should read, because it depends on the time that you need to process these records. But you should configure the batch size accordingly, not to exceed this maximum execution time. So this is a way where you can use AWS Lambda for serverless processing of, well, streaming data. Now, you've been very patient. Thank you for that. I was talking about Kinesis and about MSK. And now you probably ask, what is the difference? When should you use which? If you look at this from a high level, it looks very similar, no? For Kinesis, we have streams with shards. For Kafka, we have topics with partitions. But where's the difference? This is very similar. That's not worth taking a picture, in my opinion. The thing is, if we talk about Kinesis, you get the classic AWS API that we built for you from ground up. We give you a throughput provisioning model that I was explaining, where I said, look, isn't this amazing? You just define the throughput, we provision it for you, you pay for the throughput, that's it. You can scale seamlessly. If you need more shards, you get more. If you need less shards, you can have less. Retention time typically is a day. You can extend it up to 7 days. And it's deeply integrated into all other kind of AWS services. Kafka, on the other hand, it's open source. This is probably why you like it, why you're here, because you already might be using Kafka on premises. You're looking for an easy way to migrate from on premises to the cloud. then it's fantastic. It gives you a cluster provisioning model. You pay per broker in the cluster for the broker instances and for the storage, but you're not paying for topics. That's super cool. Now imagine this. If you need 1 million of topics, you can have 1 million of topics. Now you probably say 1 million of topics in a Kafka cluster. Does it make sense? There's Kafka clusters in productions that use thousands of topics, and it's built to support hundreds of thousands of topics per cluster. The real question is, what is the throughput that you want to achieve? Can you achieve it with your cluster instances? And that's a big difference, this cluster provisioning model versus the throughput provisioning model. And you can have this retention that is default for 7 days. You can set it to forever. Remember the New York Times example? This is why I showed you this. They never expire the messages. They keep them forever. And there is like really strong third-party tooling. People love the tooling around Kafka. That's, you can use all the tooling also for MSK because it's standard open source Kafka. It's upstream Kafka. We don't change it. With this, I want to say thank you. Hopefully you could get a good overview of using streaming data with Kinesis or streaming data with MSK. Remember, MSK so far is preview only. You can try it today. Contact me if you have more questions. I'll be around. I think we are on Twitch. Maybe we have some questions coming from Twitch.
Yeah, we have a couple of questions.
Okay, cool.
One of the questions was, what was the name of the book you referenced that talks about Kafka commit logs in the beginning of your presentation?
The name of the book?
Yes.
Yeah, I'll try to flip back. The book is called I Heart Kafka. It's a bit hard to find because you have to type the heart. Let me see. This is it.
Yes.
It's written by Jay Krabs, if I'm not wrong, and it's I Heart Kafka. That's the one that really explains the Kafka details. It's a couple of years old, which is not a bad thing because it focuses on the most important things, and everything in there is still true. So it's a thin book, 60 pages. I highly recommend it. Can we take questions from the audience?
Yes, we can. I can just go over there and give the mic.
I can't hear you. Coming to you. Can I?
Here.
I'm not sure if I'm allowed to move off the stage.
I was just wanting
Sure.
to clarify because the photo says I heart logs.
I Heart Logs, yeah.
So it's I heart logs, not I heart Kafka?
No, I Heart Logs. That's a real book cover, I Heart Logs.
Oh, okay.
Yeah,
okay,
yeah.
great. Awesome.
It's
Thank
the
you.
heart that got me wrong when I was searching for it. You really have to type heart in I, heart, and then logs. That's what I thought it's I like logs or I love logs or it's I heart logs. That's what you need to type if you search it on Amazon.com. Okay.
Anyone else in the audience have questions? Yes. Coming your way.
We're using the MSK right now on the public trial. Do you know the timeline on getting it to GA and just improving it so it's goes beyond the beta,
It's
fully available?
this year and it's soon. Soon in an IT scale of dates, not in a geological scale.
Okay, cool. So
Yeah.
2019.
2019.
All right, our DevOps team will be very happy to hear that.
Yeah, that's what I hear.
Thanks.
Interesting to talk to you later if you want to share some experiences with the preview. Super interested. Cool.
Hi.
Yes. More questions?
Hi.
Yeah, sure.
There is also another company called Confluent that's already offering cloud Kafka on cloud. So how do you see MSK doing, performing as a cloud offering versus the Confluent version of the cloud Kafka? Because they have a whole suite of products like schema registry, KSQL, and all that stuff on top of the actual Kafka itself. So how do you see MSK doing against the actual cloud offering of Confluent?
I didn't get every word from your question. I heard Confluent and Kafka and how I compare
So
it.
Confluent also offers the cloud offering of
Yeah,
Kafka.
yeah,
They
I
have the
know,
Confluent
I know,
cloud
yeah.
product. So how do you think the MSK, the adaptation of MSK versus the Confluent cloud version of
Yeah,
Kafka?
I see.
Because they have the whole suite of products, right?
Sure.
Like schema registry, KSQL, and all that.
Yeah. Okay. So what we do is we offer standard open source Kafka, and as I said, it's a preview right now. It will be GA this year, and then it's up for the customers to select. We have the whole suite of Kinesis services that make a lot of sense. and they're super well integrated. And now we give a second choice to the AWS customers for open source Kafka. And I think most of our customers, they come from an on-premise world and they look for an easy migration path. And they are already using, AWS Lambda, they're using RDS or DynamoDB. And then the most natural way is to use MSK. But we are open. I mean, we want to give people choice. I think Confluent is a partner from AWS. We try and work with them together. Yeah. Some more questions? Please speak loud.
Hello. My question is, for Kafka and Kinesis, does they both support the exactly once? Because exactly once is very difficult in the streaming processing.
Yes, Kafka supports it.
How about Kinesis?
Kinesis, I don't know. I have to take this offline and maybe connect you to an SA. Yeah.
I have a question on throughput. So to increase the throughput, we have to manually do it, or it can auto scale based on the traffic?
Can you repeat the question?
So can throughput be auto scaled based on the traffic, or we have to manually configure it?
At the moment, there is no auto scaling. That's what I can say. At the moment, for the preview, there is no auto scaling. The preview is changing already. When I showed you the console where you select the version, at the beginning we only supported 1. Now we support version 2. So there's more features added. And basically what we do, very honestly, is we do what you want. So if you tell us that auto scaling is a very important feature, it's important to get this logged. So talk to me later or talk to your account manager. And then we prioritize those requests. And I think more than 90% of our roadmap is really driven on what customers tell us what they want. Actually, the whole Kafka, the whole MSK story is like this. Because, the real question is we have this Kinesis that works super well and thousands of people are using it with all this guaranteed throughput and they're happy. But then more and more people said, yeah, but we also start to use Kafka and can't you do this for us? Because literally what I told you, it's just so hard to operate it yourself. And since it was enough customers, that's why we said, look, let's build this MSK service. And the same is true for the features. It's important to get these logged and to get these communicated. But if it's a top feature that we see in many requests, we will build it. Yeah. Thank you.
We have another question from Twitch.
Sure.
What are the limits to sharding using Kafka?
Kafka is not sharding. It's using topics and partitions. So whatever you can do with Kafka, with open source Kafka, we plan to support for MSK. That's actually a very important message because there is hundreds of different ways to configure Kafka with the properties. And usually if you have a managed service, you're almost prepared to give up some control, because we manage the service for you. Now, what I hear from the service team is that they want to make it possible that you can configure this service in a very detailed way. So we want to support as many properties as possible. That's what I heard. But we have to wait and see what comes out if the first version is going GA.
And then one last question.
Sure.
Any other resources that you recommend to learn more?
Yeah, there's actually quite a lot. I think one is just going to the AWS documentation for the MSK. Then one of my favorite resources, and that's the hot tip I want to give to all of you, is go to YouTube, search for videos. There is videos from the reInvent. It's the big conference that we have every year at the end of the year. And there is a presentation about MSK. And that's the setting the bar for most people until something else is released. So checking out the YouTube videos for MSK from reInvent gives you a good start. This presentation will be shared by AWS, so you can access it. It's not necessary to take pictures. Any questions you have, you can contact me on Twitter, on email. I'll be around, just stop me. I think we just need to leave the room. So thanks again for being here. You've been a great audience. I appreciate all the questions. Thank you.